Hello, and a very warm welcome to the start of our AI for Beginners short course. I'm thrilled to be your guide as we embark on this journey together. Over the next few lessons, we'll explore the fascinating world of artificial intelligence. Today, in Lesson 1, we're laying the groundwork by understanding AI and its importance. You've likely heard the term AI countless times, in the news, online, maybe even describing features on your phone. But what does it really mean, and why is everyone talking about it? Let's demystify it together and set you up for success in understanding this transformative technology. Our main mission today is to cut through the hype and give you a clear understanding of AI. By the end of our session, you'll confidently be able to define AI using simple terms anyone can grasp. We'll also untangle key related concepts like machine learning, deep learning, and the buzzworthy generative AI so you know how they fit together. Crucially, we'll explore why having a basic understanding of AI is becoming essential for everyone, regardless of your job. Finally, we'll pinpoint familiar examples of AI you're likely already interacting with daily. Let's get started on building your AI foundation. So let's tackle the big question. What exactly is artificial intelligence? At its core, AI is a branch of computer science focused on creating machines or systems capable of performing tasks that typically require human intelligence. Think about our abilities: learning from past experiences, reasoning through problems, perceiving the world around us through sight and sound, understanding language, and making decisions. AI aims to simulate these intelligent behaviors in machines. The primary goal isn't necessarily creating conscious human-like robots like in movies, but rather making machines smarter, more capable of handling complex tasks, and ultimately, more efficient tools to help us solve problems and improve our lives. It's vital to understand that AI isn't a single piece of software or hardware. It's an entire scientific and engineering discipline. It encompasses a vast range of theories, methodologies, complex algorithms, and specialized tools, all dedicated to developing these intelligent systems. John McCarthy, a founding father who coined the term artificial intelligence back in 1956, aptly defined it as the science and engineering of making intelligent machines. This definition beautifully captures the dual nature of AI. It involves both deep theoretical understanding, the science, and the practical construction of working systems, the engineering. To truly understand AI, we need to look at its key components. Think of AI as the large overarching field, the main subject. Within AI, a very important subfield is machine learning, ML, which focuses on systems learning patterns from data. Going deeper, deep learning, DL, is a specialized type of ML that uses structures inspired by the human brain, called neural networks, particularly good for complex data. Finally, generative AI, which includes popular tools like large language models, LLMs, often utilizes deep learning techniques specifically to create new content like text or images. Visualizing this hierarchy, AI encompassing ML, which encompasses DL, is crucial. Hell, machine learning is arguably the most significant and widely used approach to achieving AI today. The revolutionary idea here is that instead of programmers writing explicit, step-by-step instructions for every conceivable situation, which is impossible for complex tasks, machine learning involves training computers to learn directly from data. Developers feed vast amounts of relevant data into machine learning algorithms. These algorithms analyze the data, automatically identifying underlying patterns, correlations, and insights. Based on these learned patterns, the machine can then make predictions, classify new information, or make decisions about data it has never encountered before. It learns from experience. A great way to think about ML is like teaching a child to recognize a cat. You don't give them a complex rule book. You show them many different pictures of cats. That's the data. Their brain learns the defining patterns. ML algorithms do something similar, but with data at a massive scale. Two main styles exist: supervised learning, where the training data is labeled with correct answers, like photos labeled cat or dog, used for tasks like classification; and unsupervised learning, where the data has no labels and the goal is to find hidden structures, like discovering natural customer groups based on purchase history. Now let's zoom into deep learning, a specialized and powerful subset of machine learning. The core inspiration for DL comes from the structure and function of the human brain. It utilizes complex algorithms called artificial neural networks, ANNs. Imagine these networks as layers of interconnected processing units, conceptually similar to the neurons in our brains. Information flows through these layers, and each layer learns to recognize increasingly complex features or representations within the data. This deep, multi-layered structure is what allows DL models to tackle extremely intricate problems, especially with messy, real-world data. However, deep learning truly excels where traditional ML might struggle, particularly with complex, unstructured data. This includes things like images, video, audio signals, and natural human language, where patterns are incredibly subtle and hard for humans to define explicitly with rules. A key strength is that DL can often automatically discover the most important features from raw data, reducing the need for laborious, manual feature engineering. Think of the analogy of vision again. Your brain processes raw light signals through layers, detecting edges, then shapes, then objects, then recognizing faces. DL learns complex concepts hierarchically in a similar fashion. You've almost certainly interacted with or heard about large language models, LLMs. The technology powering tools like ChatGPT, Google Copilot, and others. LLMs are a specific, very advanced type of deep learning model. They are trained on absolutely massive data sets, think huge chunks of the internet, to learn the nuances of grammar, context, facts, reasoning patterns, and different writing styles. LLMs are a prime example of the broader category called generative AI. Unlike AI that just analyzes data, generative AI focuses on creating new original content, realistic text, stunning images from prompts like Midjourney or DALL-E, computer code, or even musical compositions. So, why dedicate time to learning about AI, especially if you don't plan on becoming an AI developer? Because AI is no longer a niche topic for tech experts. It's fundamentally reshaping our world and becoming deeply integrated into our lives. Basic AI literacy is rapidly evolving into a fundamental skill, much like digital literacy became essential a decade or two ago. Understanding the basics empowers you personally, helping you navigate technology more effectively and professionally, regardless of your field. We are living through what many call an AI revolution, and having this knowledge helps you make sense of it all. Let's break down the importance further. AI is transforming nearly every industry, from healthcare diagnosing diseases faster, to finance detecting fraud, to how we shop and get entertained. This creates booming career opportunities, not just for AI specialists, but for anyone who understands how to apply AI in their role. Crucially, AI literacy helps you use the tools you already encounter, like search engines, translation apps, chatbots, more effectively and critically, knowing their strengths and weaknesses, like potential bias or hallucinations. It empowers you to navigate the future, adapt to change, and participate thoughtfully in important societal discussions about AI's role in ethics. AI isn't some far-off future concept. It's woven into the fabric of services we use constantly. Those eerily accurate movie or song recommendations on Netflix or Spotify, that's machine learning analyzing your past behavior and comparing it to millions of others to predict what you'll enjoy. When you ask Siri, Alexa, or Google Assistant a question, that's AI, specifically natural language processing, NLP, working to understand your spoken language and find the answer. And those increasingly common chatbots on websites providing instant customer support, they also use AI, NLP, to interpret your questions and provide relevant information 24/7. Let's quickly recap the core ideas from Lesson 1. We defined artificial intelligence as the field focused on simulating human intelligence in machines, aiming to make them smarter and more capable problem solvers. We clarified the key relationships. AI is the broad field, containing machine learning, which learns from data, which in turn contains deep learning, using neural networks for complex patterns. We also touched on generative AI, which creates new content. Most importantly, we established why understanding these basics is crucial for everyone today, impacting careers, enabling better tool usage, and helping us navigate an AI-driven future. You're already using AI daily. Fantastic work completing Lesson 1. You've successfully built a solid conceptual foundation for understanding AI. Now that you know the what and why of AI, our next step is to explore the how, specifically how you can interact with AI effectively. In Lesson 2, we'll dive into the essential skills needed to leverage AI tools practically. We'll move beyond definitions to focus on the competencies that will truly empower you on your AI journey, like prompt engineering and critical evaluation. I encourage you to stay curious, reflect on what you've learned, and get ready for Lesson 2.